Welcome to the lesson 24, the last lesson of the Advent of SysML v2 training series. These lessons are brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kęstutis, and over the past 23 lessons, we've built a complete foundation in SysML v2, from parts and attributes through connections and flows, actions and states, all the way to requirements. We completed this picture by connecting requirements to design. We have already modeled their definition and decomposition and added formal constraints for precision. But how do we actually say that a design element satisfies a requirement? By the end of this lesson, you will know how to model an element that satisfies a requirement and how to automatically verify requirements with Syside Automator. Firstly, let's address a common misconception. In lesson 22, we declared a subject for our requirements, the Santa sleigh. But here's what's important to understand. The subject does not mean part satisfies the requirement. Think about it. A requirement definition is just a condition, a statement that can be true or false. The subject only declares what the requirement is about. It does not claim that anything actually meets that condition. To explicitly assert that a design element meets a requirement, we need a separate relationship. In SysML v2, this is done with satisfy requirement usages. A satisfy requirement usage does two things. First, it binds the subject of the requirement to its parent element. Second, it asserts that the requirement must evaluate true for every instance. This is the explicit connection between the requirements and design. Let's see satisfy requirement usages in action. Here is our Santa sleigh design with the cockpit, cargo bay, and Santa himself. Look at line 27, that's the key line. The satisfy requirement keywords declare that this part shall satisfy the deliver gifts requirement. Notice this is an unnamed usage, just satisfy requirement, colon followed by the type. We don't need the name because we won't reference this usage elsewhere. What does this single line do? Every instance of Santa sleigh will now have a requirement instance of deliver gifts with the subject bound to that particular sleigh. And all constraints, including sub-requirements, must evaluate true. With one line, we prescribed that all the requirements grouped under deliver gifts must be met by every sleigh built from this design. That's the power of requirement satisfaction. It connects your entire requirements hierarchy to your design in one declaration. Now, let's look at more interesting pattern. Remember from lesson 8, we can define multiple variants of a component. Each variant can independently claim to satisfy the same requirement. This is perfect for trade studies and design exploration. Let me show you. Here's our ordinary cargo bay. It uses bottomless gift bag to hold gifts. Lines 35 through 39 declare a satisfy requirement usage for cargo capacity requirement. But notice the body. It has a doc comment explaining why this variant satisfies the requirement. This captures the rationale. Now look at magical cargo bay. It uses a different approach. It also satisfies cargo capacity requirement, but with different rationale. This pattern is powerful. Both variants satisfy the same requirement, but for different reasons. The document captures the design rationale, essential for reviews and traceability. When stakeholders ask, how does this meet the requirement? The answer is right there in the model. So we have made the claim that our design satisfies these requirements. But a claim needs a proof. How do you know it's actually true? This is where the formal constraints from lesson 23 come into play. Because we expressed our requirements with mathematical constraints, Syside can evaluate them automatically. True or false with no interpretation or judgment calls. Let me show you. So on the left we have our SysML model with Santa sleigh, ordinary cargo bay, magical cargo bay designs that each has satisfied requirement usages. On the right, we have a Python script that uses Syside Automator to perform requirement verification. It loads the model data and then checks each design whether its requirements and sub-requirements are satisfied by asserting that all the constraints are met. Now, let's run the script and see the results. So we see that all the requirements are satisfied. Ordinary cargo bay, cargo capacity requirement satisfied. For magical cargo bay, it's also satisfied. And then note for deliver gifts, requirement for Santa sleigh, it actually is hierarchical structure. So it has sub-requirements and each of them is also satisfied. So that's good news for our design. So that was a happy path. But what happens when something goes wrong? Say an engineer decides to shrink the cockpit volume to save weight. They may not realize that this might violate a requirement. Let's go back to the model and change the cockpit volume. Here on line 8, we changed it from 500 to 300 and then save the model. So now let's run the verification script again. We clear the previous script output and we run it again. We can now see that some requirements are now not satisfied. For example, cockpit size requirement has been failed. It propagated upstream, so cockpit for Santa requirement is also not satisfied. And then finally, requirement deliver gifts is also not satisfied. The engineer immediately knows which requirement failed and can trace it back to a specific constraint. That's requirement traceability, built into your model and automatically verified. So where would you actually use this? Here are a few example scenarios where automated verification really pays off. For design reviews, you can run verification checks before a milestone and provide reviewers a pass-fail report. For trade studies, you can compare variants and see which ones actually meet the requirements. For what-if analysis, you can change a value and instantly see the impact. And in CI/CD, run the checks automatically on every committed change to your SysML model, ensuring that design is always meeting the requirements. Let's recap. Satisfy requirement usages are the explicit link between requirements and design. They bind the subject and assert that all constraints must be true. And with Syside Automator, you can verify those claims automatically. Failures propagate up the hierarchy, giving you the immediate visibility into what's broken. Your final challenge: complete the requirement story for your stealth mode model. Add satisfy requirement usage to connect your stealth mode requirements to the appropriate subsystems. Run the verification script to confirm all requirements pass. Then try breaking something, reduce a value and watch verification fail. Check the blog post for full details. And with that, we have completed all 24 lessons of the Advent of SysML v2. Congratulations on making it through! You have learned the foundations of modern systems modeling. Week 1 introduced structure, definitions, usages, specialization, modifiers. Week 2 added organization and connectivity, packages, attributes, connections and flows. Week 3 brought behavior and automation, actions, state machines, simulation and CI/CD. And week 4 completed the picture, requirements, constraints, satisfaction and verification. You now have the knowledge to start modeling real systems with SysML v2. The language has even more to offer, and we are excited to see what you'll build with it. Thank you for being part of this journey. Continue sharing your experiences and asking questions in our community forum. Links and information on Syside Cloud Access are in the video description below. Like the video, subscribe to our YouTube channel and click on the bell icon to get notified about future content. Take care and happy modeling!